Good morning, everyone. We're back here at Sebastian's. As we saw yesterday, Sebastian explained to the class exactly how the water needs to move across this property and what our jobs are for today. So today we split up into teams and we're just getting these different parts of the job done. As you can see, they've already got the tank up on the pad. There's a team hooking that up to the gutters. I'm going to be in charge of this team back here. We're creating that little wedge of road base to direct that road water into the swales over here, and then we have other teams getting those swales leveled out and finished off. So I'm gonna keep working on this. I'll check back in. So a little bit later in the morning, continue working on this little project. So we got our little drainage channel defined and got the slope set on that, punched through the fence right there as well, and then we started adding our road base here. Turns out we don't need very much road base at all, just to get that a little bit higher than this channel so that the water wants to go in here. So we're going to keep working over on this rain garden. We got the bottom of that level set. He's just leveling that out. And then we got to build the spillway over there and get that level right. Show you what else is going on around here. Looks like Sebastian's hard at work getting that channel dug. Kicking up dust. So they're working on hooking up the gutter over there. We've got that leaf catcher on it. Up there. And they're going to hook that up with the first flush. Get the pipe laid in, this wet line conveyance, over to the tank. Over here they've been cleaning up these swales that were roughed out, making sure they're all flat, and getting their spillways built correctly. You can see here they built this berm along the end of it so that swale does not flow into this swale. And they're just working on getting these all smoothed up.
Do you want to kind of give a brief description on why you designed it the way you did, what each portion is what function it's doing, and what steps you have to do after lunch?
Yeah, so the first step we did was put the leaf catcher on, and we still have to cut that metal downspout in half so that leaves don't get stuck at that exit of the downspout. So after we cut that top part's done, and then it's not glued between the leaf catcher and this elbow because Sebastian wants it to be easy to take the leaf catcher off. I don't know why you wanted that.
Sometimes it's material gets through the screen and sits in the bowl of the leaf catcher, so it's nice to be able to take it off
and wash it.
Yeah. That top screen comes off, but if you look at it now, the top screen won't come off because it's pinned in by that shiny metal tube. So that tube will get cut off to half its length, so that one, material doesn't come down it, hit the screen and get blocked, and two, so that screen can get lifted off and cleaned once or twice a year.
Yeah, and then we took it off to an angle so that the first flush wouldn't be too far over here. Like if we had done it just straight over and the first flush was here, then the downspout would have been blocking this electrical meter or whatever this is. So we took it at an angle so that the downspout would be clear of this. So we have a 45 degree that we still have to attach, and then the downspout will come down here. And yeah, we just connected we glued all the connections for the first flush, and forgot to put the ball in there. But Sebastian doesn't think that the ball is very useful anyways. I don't know. Yeah, it's pretty straightforward, just connections and reducers and angles.
I think OAC in your in one of your guides, you have a kind of a good description of this, right? Of the ball valve.
In the Brazilian ball pre-filter. But yeah, that was kind of the early days before then manufactured, purchased ones and little drippers and things and other stuff showed up. So that's what we did back in the day.
Yeah, and we still have to do the straps connecting it to the wall. Right now, it's held up by me.
It's really your sense, and in this instance where we're not under a forest system, we're sort of like Doug fir, Like those conifer Doug fir needles that float a lot, like if you've got lots of leaf litter and detritus and debris that's accumulating on the roof, it's going to get through.
What we're going to want to add is another T in the 3-inch pipe around here, because someday we'll run a line to the back side of the house to put another leaf eater on that other gutter.
Okay.
Won't do it today, but we're going to leave that T and we're going to glue a cap on it so that later on all we have to do is come in, sawzall the cap off, and connect our other pipe going to the other downspout.
Is that gonna be underground as well?
It'll be an underground connection, because we'll run that other pipe in a trench along the back of the house. And we'll help it.
Hey, wait, one last thing I just want to mention, because I noticed it with mine. If you are in a place where you do have a lot of leaf litter on the roof that's washing in, one thing that can happen sometimes is it can get caught right between the little downspout, that little metal piece that comes down, and the leaf catch.
Yeah.
Sometimes material gets caught right there.
Right.
And so you have to watch that in really high flows, because
We're also gonna cut that metal downspout.
I think that's a good idea, because I think it's actually a little close. But if you don't have quite, if a chunk, you know, let's just say there was a big windstorm and a big eucalyptus leaf blew over here, then got jammed up in there, that becomes the weak
Yeah, I
point.
think we should wait for a second. Let's wait
And
until we're...
that becomes the weak point, and then, you know, and then it starts filling the gutter up, it might not be able to get out of the leaf catch, or it starts spilling off the leaf catch, so. Just one of those little maintenance things, those little leverage points, right?
Yeah.
You have this whole huge system, and then a eucalyptus leaf
No,
messes
literally.
the whole thing up.
we did a system that took the entire house into 30,000 gallons of storage, and had sycamore tree above it, and we didn't cut those. And so one, it got plugged up, and we lost a bunch of storms. And two, when we went to go tell him, oh yeah, clean the screens because it got full of sycamore fiber, he couldn't get the screen off because it's wedged in right now by that metal thing. So now we cut them to half, but
Little thing.
you can't wrench on them because you'll twist them out of the gutter. That's annoying. Done that.
Yeah.
Conveyance group?
Conveyance.
Rosie.
Okay, so we started, there's an electrical line that's 18 inches down. We laid the warning wire, warning tape over it, then buried over it. Took a picture as well to document before. And then we brought it up to 12 inches above the ground. And we have yet to kind of like eyeball the slope that's going to run from the first flush over to the tank. But we've dry fit the 3-inch pipe that's going to run through. And so you can kind of see there's a bow in it. I spent a bunch of time chipping away at this edge to make this bow, to make it fit, because it was a sharper angle before. It's going to come in through here.
Now, Hiroshi, did you all glue these connections?
No, they're dry fit.
Dry fit. And you keeping them dry fit?
No, we will glue them.
You're gonna come back and glue them after.
That's his fault, but yeah, we're going to.
So you're testing out your lengths and your runs before you glue.
Right.
Yeah, gotcha.
Are you gonna teeth it?
There, let's see. So this is the in, so there's no T there. There will be
But didn't he say he wanted?
a T.
In the conveyance line.
I mean,
T for the drain.
yeah, so the drain is right here. We didn't have a T, so we've got this, the clean out valve instead, but I think it'll work. And it's gonna come, let's see, feed in, kink at a 45, 3-inch, then we'll cut it, attach this, and this is the drain, so when you wanna clean out the wet line, you can open it and it'll drain into this pit, which has 4 inches of gravel, plus a gopher wire basket underneath, mainly so they don't dig up dirt into it and fill it up. And then it'll be accessible through the black hole, and it'll need to be cut into it, and it'll be tilted at a slight angle, so when you want to flush it, it'll drain into here. 3-inch will come close as possible to the tank. Then it'll come up 3-inch, and then there's a bunch of reducers, and it'll have a male adapter that goes into the black top hole. So that's everything for the in. And then for the out, that's over here, there's the brass valve, a T. We'll reduce this the jumper section down so that's really flush. And then it'll be right outside this line, the in line. There'll be a hose bib on the right, and then the left side will go and, this is a 2-inch, and it will reduce and convey over to and connect with the systems over there.
It'll go into, first it'll go into a pump in the well house, and that pump will then send it to those 2 pipes. One of which goes down that way and it'll end up being irrigation for the farm area, and the other one, which will go back into this trench, will go back to the house and then later along to the garden in the backyard.
So you're gonna manually?
So those 2 pipes that are the irrigation pipes will go into the well here, and we'll have a pump with another pressure tank and a series of valves in there, so we can control, like, well, we'll send water down to the irrigation areas, but then maybe during the winter when we're not irrigating, we'll close that valve. So if the pipe gets broken, we don't run a bunch of water through it. So always nice to have extra valves to be able to isolate systems. Couple features on this. He's putting the pipe here that goes up into the tank, not right in front. You notice the fittings are on top of each other, and very frequently somebody will go out and down. And then the pipe's here in the way of anything to use the tank water, which kind of sucks. So he's going to have to play a game of up, angle, angle to be able to get into that fitting, which gets a little bit tricky. You have to mock it up in dry and by hand. To make sure you got all your angles right. You're hemmed in by, you only have certain angles of fittings that you can buy. Another thing that I think I'm going to do here is, I don't know how much these things are going to settle. This is very rigid pipe. It doesn't bend at all. It has no give. So what I don't like having is things will settle differently, and if they're connected by hard pipes, you'll start putting strain and stress as things bend. You'll see a lot of these tanks sometimes with the pipe going up into the top and the pipe's bowed out to the side because the tank has settled more than the pipe did. So the tank's now pulling the pipe down and bending it. So to adjust for that, what I'm planning here, because this is low pressure, we're going to cut the pipe and use a black rubber connector. It's like a sewer connector. It's in one of those buckets, black with 2 hose bands around it. And we'll leave like a half-inch gap in between this pipe. That way, as this tank settles in the first year of getting heavy, so that we'll cut the pipe and we'll leave a little gap in between the 2 sections of pipe. And as the thing settles, we can loosen this and let the pipe kind of adjust to a nice straight, unstressed condition, and then tighten these up again. This isn't sealed enough for pressure, but there's no pressure in this line. So this will give us enough of a seal that we'll, we won't risk this tank settling at a different rate. Similarly,
We could also, like, we've installed them at the top, coming out.
yeah, that'd be another place to do it. The other thing we're going to do here, this pipe isn't going to go straight down into the ground and over to the tank. If it was going into the ground, into a trench to go somewhere, consider that the tank's going to settle and that pipe in the ground is going to settle a different way. That is a really easy way to break a pipe, which if it's at the bottom of your tank, you're very unhappy because you just drained your tank. Yeah. So if we're going to go here, say we're going into the ground, we'd use a piece of flexible PVC. It has to be sealed, but somewhere around, oh no, it's back in the truck. They make PVC tubing that bends a little bit, sometimes called spa hose. And it's just like PVC, it glues like PVC, and it gives us that little bit of bend. So when we make our connection going out to the pump, that flexible pipe gives us the ability for this thing to flex around a bit. Yeah.
Why don't you use that as the top?
Yeah, we could use that as well. The trouble is, it's flexible, but not that flexible. And so we would have to use it in the horizontal position. It wouldn't, if we use it in the vertical, it would, it starts looking really weird because you have this thing where it's a bent, wavy section. If we used it across the top, we're only planning like 8 inches. Like this is going to be real close. And 8 inches of that or 6 inches of that basically gives you no flex. It's quite stiff. So we could if it was a longer run. When I'm using it down here, I don't go pipe and then put it into the ground right there because 6 inches of flexible PVC is not enough to give you any real leeway. I'd come over about a foot or 18 inches and then into the ground. That gives me enough play.
The other reason on the flexible from the bottom of the tank isn't just settling, but it's seismic. When you get an earthquake and all hell's going having some flex on the out supply that doesn't break to drain your tank is.
Yeah.
Is that what they're talking about when they say flexible connection required?
Exactly. You don't want this tied into the ground because even if the pipe doesn't break, it might break this bulkhead, or it might bend the bulkhead enough to start it leaking. If this I'm less worried about it, because if this breaks, I don't lose a tank of water, right? And this already has quite a bit more play because it does have 7 feet of pipe in the air. So you could also use like a slip fix here, because that will adjust. But a 3-inch slip fix is like $60, and that was $250, so I'm using that.
Fill into that swale, and before it has the ability to overflow the swale, it's going to spill into this catchment channel here. So what's going on right now is that this section right through here to about this point is all high. So this section still needs to get channeled out in here, probably around 4 inches, which you might have to make the rain garden a little bit deeper, just so for water flow purposes.
And why does it have to go deeper?
Because right now this point here is about 6 inches higher than this point down here. So this isn't going to allow as much flow into this section, and this will actually puddle down here and not be an equal retention. So then if this is higher, then this point here,
It'll just keep flowing.
it'll just want to go.
It won't backfill.
It'll just bypass.
Exactly. Exactly. Yeah, we really want that back flood because, when we're thinking about these systems, don't think about this in the nice little gentle rain with the little tiny bit of water. That's not how to gauge how these systems work. You think about it in the 100-year storm event, that happens every year. That is, super high flow in a short period of time, and water's pushing through here. And is it going to even get into this thing? Right now we currently have a 1-inch difference between the spillway and here, and likely a little percentage will, but a lot of it's just going to bust through and head on down. So we want to take the whole idea of a backflood swale isn't just about infiltration capacity. It's not just about spreading. It's about energy release, right? You've got all the energy of the water and a high flow, and you want to take some of that velocity, some of that energy out by making running water walk, and spread. And so this is a key little factor. I mean, we're just into inches here, but it'll make a big difference to avoid a blowout, because what's going to happen is once it goes all over this, now we're into a diversion channel, and now it's going to pick up speed again. And we would rather have this be gently sheeting over to head down there rather than busting through with no energy release.
So some digging there and some grading out.
Nice.
All right.
Yep, bringing that down, adding some more here, and then just checking these levels, making sure they're good.
With the laser level.
Yeah. And of course, if you wanted to take a little extra energy out, you could go a little deeper here. We don't have to, based on Sebastian's, keeping things real smooth. But you could go deeper. If the rain gardens went deeper, you're going to be able to catch more sediment. And in low flow, you'll have a little bit more of a energy release. In high flow, the whole system's going to be full. It's all saturated, and it's just going to move. So. Okay, so I was digging this out. So basically now we've got this diversion channel. It's not that big of a distance, and it's not that steep. So it's not like, this isn't like a shotgun culvert, like, crazy drainage. But this is where the water's going to speed up. If there's anywhere in this system where the water's going to pick up speed and potentially have an erosion issue, it's going to be in this diversion channel and that one over there. And so what we're doing, which is really smart, is at the end of the drainage, we have another rain garden. So again, we're taking energy out. And my suggestion would be that this little section here is a section to be armored. because it's going to get the punch from a high flow. It's going to come in, and then like Brock was saying, taking a turn, it's basically going to hit right here, boom, and then it's going to start slowing down and kind of spiraling out before it moves. So this zone right here is another erosion hotspot, another weak point that wants to have, probably some structural armor there. And then it'll back flood into there.
So here we had kind of a challenge because this, as it was measured out, was going uphill a little bit. And so we were trying to continue with that. Oh, sorry guys, I'm upsetting the yellow jacket. So we're widening and then also being mindful of like Sebastian or maybe Ray someday coming through with a wheelbarrow and being able to go over these without hitting a really hard jump. So this is doable, this is not. And we kind of kept peeling back the whole way through and trying to get it just barely high enough here that it wouldn't bust over as it's trying to get over there to the eventual rain garden.
Tom?
Do you think it would be worthwhile to put any sort of check dam thing in this area, or do you think that would maybe create backup and then lose it, just as an additional measure to slow it down to prevent that potential blowout there? Just like a shallow one.
Yeah, I think check dams would be cool. I think because it is so shallow that you just have to be careful that you don't build it up so much that the water wants to punch outside of the drainage. So, really keeping it low in the middle is key. And then again, the resiliency of does some floaty thing come in and get caught in the middle of a check dam is something to watch out for. But
so it looks like they've got the wet conveyance line installed. Starting to fill it in the ditch here. Got it connected up to the tank there, that flexible connection Sebastian was talking about.
there's plastic bulb.
Closer and closer. So we finished up over here. This little system, we poured a couple buckets of water down the ditch to make sure that it was moving right. As you can see, we put some gravel in the ditch just to hold it together a little bit. And looks like all the swales are pretty much ready to go. They've been smoothing them out, making sure they have the appropriate height above the bottom, or above the spillway for these swales. Sebastian wanted 3 inches of height on the berm above the spillway, so there's no danger of that water overflowing the berms. But in the last little hour of the day, we added this feature here as well. So this is this ditch below the work we did up there. All the water that catches, and then there's a speed bump here which catches water that's coming straight down the road and puts it into this ditch. So before, all that water would just collect on the driveway over there, making it pretty hard to get in and out. So we checked the contour, and it was possible to dig this other small swale and direct that water from here over to the driveway a little bit further in, where that other rain garden, where all these other swales are going to overflow. So kind of just directing this water around this corner. It was pretty easy to do. All we had to do was put a small little check dam spillway in this ditch here. The top of that spillway is 3 inches below the road, and this swale here is another 4 inches or so below that spillway as well. So again, if this thing ever gets clogged, or he wants to not catch that water from the road, he can put sandbags there, and that water will just go over the spillway and keep going down the ditch without flooding the road. So we're just about to wrap it up. It's been a really great workshop. It was cool to be a part of this and help out with the setup. Come out here with the excavator and mark all these swales out and see the whole this process. It's been really cool. This water harvesting workshop's been really informative and had a lot of fun, so I hope you guys did too. I enjoyed watching. If you like my videos and you want to help support the channel, you can go to patreon.com/JesseGrimes and become a patron. Thanks for watching. See you next time.